Hi, everybody. This is our second of two videos um, regarding math team contest problems. I thought we would start with just a tidbit like we did on the last one. We'll see if we continue to do this as we continue this series. But the tidbit I decided to talk about today was a perfect number. Let me give you the examples of two perfect numbers. 6 is the first perfect number if you take all of the numbers that are factors of 6 besides 6 and add them up, you get 6. And the next perfect number is 28. And so the numbers that are factors of 28 that are not 28 are listed there, and they add up to 28. Turns out that perfect numbers are very rare. The next one is 496. So, like, if we kind of thought about how do you get 496? 1 times 496, 2 times 248, 4 times 124, 8 times 62, 16 times 31. If you added all of those numbers up besides 496, you would get 496. And so 496 is perfect. So they're pretty rare. The next one is like 8,128. Turns out that there's a formula for this. You could take uh, 2 to the p minus 1 times 2 to the p minus 1. If p is a prime number, then you get a perfect number. And so the first prime number, of course, is 2. And so this one is 2 to the first, which is 2 times 2 squared minus 1, which is 3, 6. And so you could try that again. You know, the first few prime numbers are 2, 3, 5, 7, 9, etc. And anyway, you would be able to create some perfect numbers. And so you might think, well, what are the numbers that aren't perfect? Well, just to give you an idea, like say 15, the factors of 15 besides 15 are 1 and 3 and 5. Those add up to less than 15. So 15 is what's called deficient. And then say a number with a lot of factors, just pick one, maybe 24. 1, 2, 3, 4, 6, 8, 12 all go into 24. That's bigger than 24, right? So I should have less than signs here and greater than signs here. And so 24 is an abundant number. All right, so that's your math tidbit of the day. What's a perfect number? Okay, so let's as we did on the last video, let's talk about some math team problems. And so let's do number 2 this time of the 2024 test. In the algebra 1, so the freshman math teamers would have to answer this question. 3 less than twice the number is the same as this number increased by 7. At this point, maybe you should pause the video and try to solve it yourself. And so if I was solving this one, I would say 3 less than twice a number is the number increased by 7. And so we solve this to be x equals 10. And so there's your answer for the algebra 1 question. The geometry question on this particular math team exam, question 2 says, it's a yes or no question. It says the degree measures of a triangle are in the ratio of 3, 4, 5. Determine whether the triangle is a right triangle or not. You know, they're trying to catch you here on the Pythagorean theorem. If the question was the sides are in the ratio of 3, 4, 5, then the answer would be yes. But it's not sides; it's degree measures. And so the truth is that the angles of that triangle in question could be found by solving this equation here, and you would get x to be 15. And so actually the angles are 15 times 3, 15 times 4, and 15 times 5. And so those three would be the angles that are in that ratio, and they're clearly not a single one of them is a right angle. And so the answer would be no. as far as the Algebra 2 or the junior portion of this test, let's see what it says. It says the letters A, B, C, D, and E are written on different slips of paper and then placed in a paper bag. Let K be the number of ordered arrangements that can be made of all the letters as they are drawn from the bag one at a time without replacement. And let W be the number of unordered arrangements that can be made when 3 of the 5 letters are drawn from the bag one at a time without replacement. And so K is in this case 5 factorial. There's, basically you could think of it this way. There's 5 ways you could pick the first one, and then 4 ways you could pick the second one, and 3 ways to pick the third one, and so on. And so K is the answer, is the number 120. And W in this case is it's a relatively easy combination problem if you're familiar with the concept of combinations. In these counting problems, sometimes the answer can be found using either a combination or a permutation. I would encourage you to look it up. A combination happens when you have a situation where you have no repetition allowed, which is this deal where it says without replacement, and then order doesn't matter. Okay, and so W says it's the number of unordered arrangements that can be made when 3 of the 5 letters are drawn, and so W would be commonly written as a combination of 3. Choose 5. The formula, as you might recall, is 5 factorial over 3 factorial divided by 5 minus 3 factorial. Now, this is all well and good, but it is also true 3 factorial is 6, 5 factorial is 120, 2 factorial is 2. It's also true that you could do this on your calculator, right? And so it's a time test. And so if you had a graphing calculator, let's talk about that a little bit. You would hit 5, hit the math button on a TI-84, go over to the probability menu, choose NCR, and then hit 3, and you could notice that it just gives you 10. It doesn't mess around with the formula. I'd be happy to talk to you about why the formula works, but anyway, in terms of the math team and getting the answer quickly, you would now take K divided by W, which is what it asks you to do. So 120 divided by 10 is 12. And so the answer here is 12. All right. A permutation, by the way, is where repetition is allowed and we're worried about the order. Okay, worried about the order. But that's not what this question asked. Okay. Moving on to the pre-calculus question. It says an airplane travels due east for 210 kilometers before turning 7 degrees south and flying for 100 kilometers. Okay, so let's draw a little picture here. 210 due east. It turns 70 degrees south. What that means is that it's now on this path, all right? So the airplane went east and now 70 degrees south, and it flew 100. And now it wants to determine the distance in kilometers of the plane from its starting point at the instant it finishes that 100 kilometers. And so it wants this distance right here. Okay, maybe we'll call it N. All right, so this angle is 70 degrees. That would mean that the angle that I'm pointing at here inside the triangle is 110 degrees. And so now we have a triangle where we have the angle and its 2 adjacent sides. So we have a side angle side situation. And so those of you who have taken some trigonometry know that this could be solved using what's called the law of cosines. And so the law of cosines, we would say that n squared equals 210 squared plus 100 squared minus 2 times 210 times 100 times the cosine of 110. Okay, and so I'm not sure why I had a degree symbol there. Let me get rid of that thing. And so we're here, and so we would get our calculator out. Let's see if I can get everything on the screen at the same time. There we go, maybe. And we'd make sure we're in degree mode for one thing. We are. And we're going to end up taking the square root of that business. And so again, speed is of the essence. So we'll hit square root 210 squared plus 100 squared minus 2 times 210 times 100 times the cosine of 110. Some bad handwriting there. That's 110. Whoops, 110. And it appears that we get 261.658. And I believe it asked for our answer to the nearest thousandth. Okay, let's double check that. It did. By the way, this is an opportunity for you to, math team can be an opportunity for you to learn how to program your calculator, do a little programming. It's good for your computer science skills. As an example, I have a program that calculates side angle side situations. So we'll just double check our answer here. One side was 210, one side was 100, and the angle was 110. And you can see from my program that we get that side to be 261.658. And so speed is of the essence. And so sometimes if you have your calculator programmed ahead of time for some math team, then you might find yourself having more time to solve some of the other questions. All right, hope you enjoyed this video. It's the second one we've made. Have a good day.